In this video, let's continue where we left off, right where we left off in the last one. All we did in the last video was download the animations, put them into Unreal, create the avatar, set the avatar to, our animations, and then just like rename them and set the ones looping. Just kind of like some setup that we needed to do. Now let's actually look into the animations themselves and how we're going to control them. So I'm going to click on Remy and there's going to be an avatar component on the base model itself. Now, if this wasn't there, for example, if I remove this component, you can always come in, add a component of type animator. Well, I did animation. We want animator. And that's basically the same thing. We just need to set the avatar to whatever our avatar is. And we need to assign a controller to it. This is an animation controller. So we can just make one. I'll just do it in animations. Right click, create, animation, animation controller. And I'll call this Remy controller. And then we can just associate that with our animator. So let's double click on I did before I said it. Let's double click on the controller. And that's going to open up this new animator tab. If you don't have it or it doesn't open for some reason, you can find it in Window, Animation, Animator. Now, this animator tab, and really the way we handle animations in game engines, is through a state machine. So we're going to have states and we're going to have transitions. And we can see our whole animator, the state machine, has an entry and an exit. That's very similar to our on enter and on exit. This is for the whole state machine. And then finally, there's this any state, which just says this represents kind of any state as it says. And if you connect this to something, that means you can transition from any state to that new state. We'll take a look at that. But this is essentially where we are going to set up all of our animations. We're going to have states, so like it comes in with these 3 states. And we're going to have transitions. We can base those transitions on different variables that we can make in this parameters tab here. So there's layers and parameters. So we're going to put a bunch of parameters here and we can base our transitions off of that exactly like we're doing in our code. This is a visual representation of that. And this is how Unity handles their animations. Really, this is also how Unreal handles their animations, is with a state machine. So, we could drag the animations in here. So I dragged in jump. You can delete them. And when you drag them in, you'll notice that entry immediately connects to that animation. Because what's happening is that the first animation we put in, it's just going to be, when we start the game, it's just going to put us in that animation. And real quick, I realized I forgot to download an idle animation. So I'm going to do that real quick. I'm going to find an idle animation on Mixamo and add it to my game. So just search idle and something like this is fine. Just some idle animation. Let's download that and put it in our game. Make sure we download it without skin. Okay, and now I have this idle. Again, just set up the rig, humanoid, copy from another avatar. I want to copy it from Remy avatar. Save it. And, rename the animation, idle. And I realize I forgot it because I think the best way to kind of show how the entry state works is just to toss our idle animation in here. I'm going to put my animator on this side for now, just so we can kind of see both of these at once. And I'm going to hit play. You'll see our player is now in idle. And we can also see this entry has put us into idle, because we can see a little blue bar under idle that's showing the animation playing. And really, I also want my idle to be looping. Now when we look at it, you'll see that blue bar just going up constantly. it'll go up, finish, and it'll just kind of restart. This is like the animations link. So you can see our character's idle. I can move around. They're still just kind of idled. Now, I'm not going to use this idle just as is. Instead, what I want is to kind of set up my states in a way where, we can have all our animations in there and we can set up some transitions. And let's just think about really what we want, right? When I start the game, we should be at idle. When I start pressing keys, like WSAD specifically, I want it to start playing the walk animations. If I press W, it should play it forward. S should also just play forward. A and D should play left and right respectively. If I hold shift, it should go from walking to sprinting. If I let go of shift, it should go back to walking. If I press spacebar, it doesn't matter if I'm walking or sprinting. We should go into jump. And when we reach the peak of our jump, start going downwards, it's got to play the falling animation. If I walk off the ledge, it should also immediately go into the falling animation. And from any of those states, falling, jumping, walking, sprinting, I should be able to dash. So that's the useful of this any state here. We can just plug our dash into any state. And when I'm done dashing, if I'm in the air, I want to fall. When I'm done dashing, if I'm on the ground, I want to go back to walk or sprint, whichever, depending on if we're holding shift. Let us just start by dealing with the walking itself first. So we could, plug in walks, right walk, left walk, forward walk, and back walk all in here. But there's a special kind of way to do that, especially with walking animations, things that, it's basically the same type of state walking, but we have 4 different animations depending on some parameters, right? Our movement. So depending on the movement buttons we press, we need to change our walking. Let's add some parameters to kind of house those movement parameters. With parameters selected, I'm going to click plus and add a float. I'm going to add 1 float for move X and 1 float for move Y. Now, just like when we did the inputs, it's very important you keep the exact same, like you remember what you name these parameters. I'm always going to start mine with a capital letter. So I just remember that, because just like with the inputs, we're going to have to kind of put it into a string. So if you don't name them correctly, it's just like a small error we can run into. So I have these 2 parameters here. I am going to right click. In fact, I'm going to put my animator back here because we're going to need the inspector part. I'm going to right click anywhere in the animation area and go over create state and create a new blend tree. We can double click to go into the blend tree. And what a blend tree does, as the name kind of suggests, is it blends between animations. Rather than just switching animations, we can blend between them. Our blend type up here under the name blend tree. First, I'm going to actually rename it. I'll call this locomotion _ walk, just to kind of symbolize what it's for. It's for walking. I'll change the blend type to 2D freeform directional, because we are going to have 2 axes. We're going to have the move X and the move Y. Where it says parameters, you can see move X, and it's just going to say move X again. Change one of them to move Y. And in the graph, you'll see there's 2 parameters here, move X and move Y. Finally, there's a list of motions here. It says the list is empty. Well, I know what motions I need. I have walk forward, walk backwards really, but it's a forward animation, walk left, walk right, and then idle when we're not pressing any buttons. So I'll start by adding just 5 motion fields. And you can see it kind of pops them in here. And each motion field has a motion. That's going to be the animation that plays. And when do we want to play that animation? What X value and what Y value do we want for that animation to happen? So I'll just start off by clicking on the little circle here and choosing idle. Well, when do I want idle to happen? If we're not pressing any buttons, right? So again, XY, this move XY is going to represent our input. So W will be 1 on the Y, S will be -1 on the Y, A will be -1 on the X, and D will be 1 on the X. So we're just kind of defining the inputs in terms of 2 floats. So we're not pressing anything, both are 0. It is going to be idle. We'll deal with walk forward first. Walk forward happens when we don't press anything on the X, but our Y is 1. We're pressing W. I'm going to do walk backwards next, which is just going to be walk forward, which will be -1 on the Y. Next, we have walk left, which is going to be -1 on the X and 0 on the Y. And finally, we have walk right, which is going to be 1 on the X and 0 on the Y. And so you can see here, up here with this little graph thing, that everything is kind of moved into its place. If I hit play now on my animation, it's just going to keep looping. And we can click and drag around here. If you look at the main graph here as I'm dragging around, you can see the X and the Y's are changing. And if I start moving towards a direction, you can see it plays that animation. This is very nice, very convenient. This also kind of sorts out if you're using a controller and you lightly press one of the inputs rather than just immediately going to our walk, you'll actually get the animation playing slower first until you push it up all the way and it's playing at full speed. And the other nice thing here is you can see, I have walk left and I have walk forward. If I go in between it, it kind of like blends between those two animations and gives us like a mix between forward and left or forward and right, whatever, which very nice. And also when we don't press anything, we're just in idle. So this is what a blend state does. A blend state just takes parameters and it kind of lets us blend between different animations based on those parameters. So just like I made this one, I want another blend state for my running. So I'm going to go back out to my blend tree. Let me just name this blend tree the same thing, locomotion_walk, so that it shows here. And I'm going to make another blend tree. I'll call this locomotion_run. Locomotion_run. Let's go in here and let us do the same thing we did before. Let's click on the blend tree. Make it 2D freeform directional. One of them is going to be move Y, and let's add 5 motion fields to this. Same thing. I want one of them to be idle, one to be run forward. I want another one to be run forward. One of them can be run right, and the other can be run left. It's going to set them to the exact same numbers as we did before. And then hit play and to just make sure it works. Make sure that whichever ones you chose, it works. Awesome. Okay, so that's our movement kind of state setup. So rather than doing one animation per kind of movement, we can bundle up all our movement animations into one state. All our walk animations is this locomotion walk state. And all our run animations is locomotion run state. These lines here represent the transitions. So let's just kind of like in that same vein, let's just quickly get the rest of our animations in here. I'm going to have jump. I'm just going to drag jump in here. I know I want dash, so I'm going to drag dash in here. And I need my falling animation, so I'm going to have falling in here. We don't need exit. Exit's useful either when you have different animation controllers that you want to go to, but we don't need that. Or when you have different animation layers that you want to go between. But we're not doing that. That's like a slightly more advanced thing. We're just going to take these bits we have here and kind of get them working. All right, let's just organize it a bit so when we start creating a spider web of transitions, it looks okay. So to start, I'm going to need some variables, some more parameters here to kind of help me know when to transition. The nice thing is that all the parameters we need is in our player motor. We really don't have to do too much extra coding to get this working. It's just setting up the transitions here. So I'm going to add those parameters first. The parameters I need is a Boolean for knowing if we're grounded. So is grounded. So a Boolean that just, and we have that in our player motor. Another one for is dashing, to know when we're dashing. I'm going to add another float for our vertical speed, which this we also keep track of. We have a variable in our player motor called gravity velocity. Well, that's essentially, we're just going to set that to this every frame. Another bool for is sprinting. And the last one I'm going to add is a trigger for when we jump. So when we press the jump key, we can just call this trigger. A trigger is kind of like a Boolean. You can set it to true, you can trigger it, and it just turns itself off immediately after that. So it kind of just happens once, as opposed to a Boolean where we have to set it to true, then we have to set it to false. But the nice thing about things like is sprinting is like we literally have a button, we have a variable in our player motor called sprinting input or sprint input. We're just going to set it to is sprinting every single frame. So we have all that like set up. I'll call it like we have all the scaffolding set up. We just need to set up our transitions and then, write a function that kind of sets these variables in our code. So to actually set transitions, to make transitions, what we can do, and I'll just start with a simple one, going from walk to run and run back to walk. You can right click on the state, click make transition, which will let us drag an arrow out, and then just click on the state you want. Importantly, this arrow represents the transition's direction. So this is saying we're going from walk to run. We cannot go from run to walk. We need to make a separate transition that goes in that direction. When you click on a transition, we are given in the inspector a nice place to kind of adjust different settings. You can set the exit time is basically how quickly do you want this animation to end and the next one to start. So imagine, we're halfway through the walk animation, you hit sprint. How quickly do I want my walk animation to finish ending and sprint to begin? In our case, because we're making a very snappy game, we don't want any exit time. Because we don't need to go to... we don't need our walk to finish in order to run start. I would just want it to quickly transition because, again, our game's got to feel snappy. So we're just going to turn off exit time for all the transitions we make. The other part is down here. It says conditions. Currently, the list is empty. And this is what's going to control our transitions. These conditions are going to be what changes the states. So I'll click on walk to run, the one that goes from walk to run. When do I want to transition from walk to run? I'll hit a plus. It's going to add something in here. And I'm going to change the condition from move x, which is just because it's our first variable, what it defaults to, is, well, if is sprinting is true, I want to go to run. And then in the runs case, if is sprinting is false, if is sprinting is false, I want to go back to walk. Fairly simple in that case. Next, dealing with jump. We can jump from both walk and run. So I'm going to make a transition from walk to jump. Just turn off exit time. Same thing with run to jump. We can transition, turn off exit time. When do we want to transition from walk to run or walk to jump? Sorry. Well, we have this jump trigger. So whenever that jump trigger is called, there's no value you can set for it. It's just when it triggers, we'll go from walk to jump. Same thing here. We want to go from walk to jump when this thing triggers. The next one we can look at is falling. A lot of things are going to transition to falling. Well, jump is definitely going to transition to falling, right? Because once we reach the peak of our jump, we want to fall. Again, remove the has exit time. And when do we want to fall? Well, if we're not grounded, so if is grounded is false, and if our vertical speed is less than, and we could do 0. I'll just give it a small negative value. So I'll do minus 0.1. So like a little after we start going downwards, they go into falling. Same thing with run. We want to transition into falling with that exact same case. If we are not grounded and our vertical speed is less than minus 0.1. And that's the exact same thing with walking. And we are not grounded. when we start falling, we want to transition back to something. So after we hit the ground, we can transition immediately back to walk. And what is the condition that we want for that? We'll check if it has exit time, but really we just want to check if we are grounded. So once we're grounded, we transition from falling to walk. You could do falling back to locomotion to run if you were grounded and holding sprint. But what's going to happen here is we're going to go to walk and immediately just go to run. So you don't need to do that. Let me just move these so they're a little more aligned so we can see them a little better. We also need to be able to go from jump to walk, back to walk. Just like we go from falling back to walk, same case. We're just going to check if we're grounded. And the reason I'm doing it from jump as well is imagine you're like jumping up a hill or a very small kind of slope where we don't start falling. We jump and we hit the ground immediately. In that case, we want to transition back to walk. We don't need to go to falling and then walk. We just want to go back to walk. And then I think the final transition we need is to dash. Dash is actually also going to transition into falling with the exact same kind of thing if we're not grounded and if our vertical speed is less than minus 0.1. And I'm going to use this any state to go into dash if dashing is true. If we dash on the ground, if we dash in the air, going into falling makes sense. If we dash on the ground, well, we want to go into walk. So if is grounded is true, we go into walk. If is grounded is false, then we go into falling. And really, that should be it for our state setup. Again, it's I think the easiest way to kind of start reasoning about these things is just think about from walking, what can our player do? Our player can run, they can jump, they can fall. Certain conditions need to be true for any of this to happen. For us to run, we need to hold the run button. So it makes sense to say, if is sprinting is true, well, we want to go from walk to run. From run to walk, well, that is sprinting needs to turn off. From walking, we can jump. If we trigger the jump, if we hit spacebar, and our whole coyote time hasn't finished, well, we trigger this jump, we go into jump. From jump, we can fall. If we don't jump off of something and we jump up a slope, we want to go back to walk. And again, we just look at the state, look at the transitions and the conditions, and we can kind of start reasoning through everything that we are doing. Now, let's move on to our script itself and start working with our animator in the script. So I'm just going to do everything in the character motor because we have everything we need here to set these variables fairly simply. So I'm going to open up the character motor. And the first thing I want to do is get a reference to that animator and so that we can actually use it. And so here, I'm going to use a serialized field, and I want a animator, so I'm going to search for animator. Animator. And I'm just going to call it animator with a lowercase a. Back in Unity, we just make sure to select our player. And you can see this animator has none. I'm going to drag Remy into that. The reason I'm not using get component here, and we can use get component. There's a special get component called get component in child, which, Remy is a child of the player. But just to keep things kind of easier and not looking at like a new function, we can just make it a serialized field and drag in the animator. That's all I've done here. Okay, so I'm going to make a new function right under get inputs, and it's going to be called update animator params, and params is for parameters. With an animator, we have access to a bunch of functions. So I have my animator variable. We can type in, if I type dot, we can type in set, And there's a bunch of different functions. We have set bool, set float. And if I look back at my animator, I've made a bunch of different parameters, right? Float, int, bool. We used a float and a bool. So set float will let us set a float value. So this vertical speed, move x, move y. Set bool will let us set these bool values, and we'll take a look at how we can trigger jump as well. But that's how we're going to set these values. So I want to set the x and the y to my input, so I can do set float and set them to my inputs. I called one move x, and I want to set it to the move input.x. Same thing with the y. I want to set float move y to move input.y. We have another boolean, or we have another variable here, is grounded. Well, I want to literally set that to my is grounded state of the character controller. So animator.set, that's a bool, so set bool is grounded to cc.is grounded. And I didn't quite explain this function before, how these functions work before, but the first parameter is a string, that's why I put it in quotation marks, is the name of the parameter, and the second is the value. So I want to set my move x, that's the name of my variable in the animator, to move input.x, which is like my movement input. Next, I need to set the vertical speed. So animator dot set float. I called it vertical speed, and I want to set it to my gravity velocity dot y. We have our is sprinting, so animator dot is sprinting, or sorry, set bool. Set bool is sprinting to input to sprint input. That's what it's called. Yep. And I think those are the main ones: is sprinting, our vertical speed, move x and y. Then I'm going to make a function just to call the jump trigger. I will call it play jump animation. And all we need to do to play the jump animation, ooh, I forgot to give it a type here, so it's got to be void. I'm just going to do animator.setTrigger, and I call the trigger jump, so it's going to set it. So it's going to fire that trigger jump. There's one edge case that we're going to look at, but I also need a function to reset the jump animation, so I'm going to call it reset jump trigger. And we can call animator, just like we call set trigger, we can call reset trigger on the name, which in this case, again, is jump. And then lastly, I just want a function to toggle on and off the is dashing, because dashing is kind of like a state that happens over time. So when we enter the dashing state, we'll set dashing to true. When we exit the dashing state, we're going to set dashing to false. So let's do public void. I'll call it set. I'll just call it play dash animation, kind of to go with play jump animation, but this will take a Boolean, and I'll call it dash value. And really, again, just like we set all the other bools, we're going to do animator dot set bool dash, and I think I called it dash. Let me just check again. I called it is dashing, comma, dash value. And those are really all the functions we need. Now we just need to actually call these. Really, we need to keep calling update animator parameters on our ground state, on our air state every frame. So right after I get the inputs, I'm going to call motor dot update animation params. Same thing with the air state right after we get our input. Motor dot update animation params. As for the play jump animation, well, if I come down all the way to my jump animation, I could just do it here. So I'll just do play jump animation. And then in our dashing state, like I said, when we enter our dash, I'm going to do motor dot play dash animation true. And when we exit our dash, motor dot play dash animation false. We can go back to Unity and see all of this working. One nice thing is you could just take the animator, and again, I'm going to put it to the side here so we can see our animations actually transitioning as we're doing this. We could see I'm walking, it's playing walking, I hold shift, we go into run, we can go back to walk, and you can see how the animations are taking time to exit. So even though my run animation's going, if I stop halfway, it just switches to walking, and that's because we didn't have that exit time. If I jump, it goes into jump, then into fall, back into the ground. If I walk off the edge, it should have taken us into fall. There you go. And when I dash, we go into dash, and then back into, falling. If I dash on the ground, once my dash goes out of cooldown, we just go back into walk. Now, the only reason I had that reset dash trigger is because sometimes if you jump and dash at the same time, there's a chance the jump trigger gets stuck, and then when I land, it tries to jump again. So I just have that reset dash trigger so that in our dash state, when we play dash animation, we are also just going to motor.reset jump trigger. So when we dash, we're just going to make sure we turn jumping off if it happens to get stuck on. But really, that was it. If this was your first time looking at state machines, this might feel a little bit confusing because, again, we made our players using the state pattern, and this is the exact same thing that Unity uses under the hood for animations. So we just created the state machine. Here, this looks more like those diagrams I showed you with the states and the transitions. We're using different variables for the transitions, but we didn't really write that much code. We literally wrote one big function. We have these smaller ones here. Well, we just have one big function, and all it does is kind of like just get inputs, right? It just takes the inputs and passes them along to our animator, which deals with setting all the different states, and it got our character animated. Thank you guys for watching.